dugsiga boardingka iyo maalinlaha ah ee Amano boarding and day school.
Now first video we have seen sine, cosine and tangent of 45 degrees angle. Now in this video we'll see sine, cosine and tangent of 30 and 60 degrees angles. Okay. Now look at this triangle. Using this triangle we'll find values of tan, sine and cosine of 30 and 60 degrees. Here it says consider the equilateral triangle. Consider the equilateral triangle given below. We have equilateral triangle here. This equilateral triangle is given with side lengths 2 units. The side length is given by 2 units. Once if we have given one of the sides, so that easily we can determine the side length of the remaining 2 sides, because an equilateral triangle, all the 3 sides are equal in length, so that side AB is 2 units, because we have given the side length of this equilateral triangle is 2 units, and again the side length of this side BC is the same, which is 2 units, and that of AC is 2 units, the same. And for this equilateral triangle, the degree measure of each interior angle is 60 degrees, because the sum of the interior angles of any triangle is 180. So if you divide these 180 degrees into 3 equal parts, because the degree measure of each angle in an equilateral triangle is the same, or the degree measure of the angle is the same, so 180 degrees divided by 3 is 60. So the degree measure of this angle is 60 degrees, and angle B is 60 degrees, and the same for this angle C, which is 60 degrees. Again we have given, it says the altitude BD or the height BD, which is the line drawn from vertex B to this point D on side AC. So this height or altitude, it bisects angle B. Bisects angle B means it divides angle B into 2 equal angles, Now angle B here is given by 60 degrees, but this BD, it divides this 60 degrees angle into 2 equal angles, That means the degree measure of this angle, the degree measure of this half part is 30 degrees. So you can write here it is 30, and the other part again half, here we have 30 degrees. And again it says it divides or it bisects side AC as well. Side AC means this side. So previously we have given the side of one of the sides of this equilateral triangle is AC, which is 2 units. Now this BD, it bisects or it divides this AC into 2 equal parts. That means the length from this point A to point D is 1 unit. It is 1 unit. And the same thing is true for the remaining part, which is DC. That is 1 unit. And then when we are saying this BD is the height or altitude, it means this BD, it forms a 90 degrees angle with side AC. So we have right angle here at point D, Now as you can see here, we have 2 triangles. These 2 triangles are right angled triangles. So the first one is BAD and the second one is BCD. So BAD, the degree measure of angle B here is 30 degrees, and that of A 60, and this one is 90 degrees angle. Now let us separate the 2 triangles and let us consider one of the 2 triangles. Okay, so this is point C, which is the vertex. This one is D here, and then the other part is B. This one is B. Now this is the right angled triangle that we divided this equilateral triangle into 2 equal triangles, Now this is 90 degree. The side length here is 1 unit, and the hypotenuse for the new right angled triangle is 2 units, which is part of the equilateral triangle given here, which is BC, that is given by 2 units. and this one, the altitude which is given by BD, is not known. It's not known. Now the question here is, what is the length of this BD? After having the length of BD, you can find sine, cosine and tangent of 60 and 30 degrees simply by using opposite, adjacent and hypotenuse of this right angled triangle. Okay, so the right angle is at D and angle B is 30 degrees. Here we have given 30 degrees, which is divided by this altitude BD. Previously it was 60 degrees, then it is divided by this BD into two equal angles. So the degree measure of this angle is 30 degrees, and this one, angle C, which is 60. Here we have 60 degrees. Now the question is, what is the length of this side BD? So we use the same Pythagoras formula to find side BD. So side BD is one of the sides from these three sides, one of the sides, but the hypotenuse is given by 2 units. So the hypotenuse 2 squared is equal to the sum of the squares of the two legs. So the square of BD, plus the square of DC, which is 1 unit, 1 squared. So what is 2 squared? 2 squared is 4. So we have 4 square unit here, which is equal to BD the whole squared plus 1 squared is 1. Okay, now rearrange this. That means collect like terms together. So we have BD square, take BD square, that is the whole squared, which is equal to, here we have 4, then switch this 1 to this part, plus 1 will be changed into minus 1. So here we have BD the whole squared, BD the whole squared is equal to 4 minus 1. 4 minus 1 is 3. So here we have BD the whole squared is equal to 3. So put both sides of the equation under radical. To find the length of BD, put this under radical or square root. Again, put this under radical or square root. So BD will be, the length of BD is equal to 3 units. The square root of 3 units. The square root of 3 units. So we have here the square root of 3 units, which is BD, which is BD. Now after having this one, here we have 30 degrees angle, here we have 60 degrees angle, and the side length of all the three sides of this right angled triangle, they are given. Okay, they are given here. Here BD, which is 3, the square root of 3 units, and DC is 1 unit, and that of BC is 2 units. After this, now identify which side is opposite to angle C, which side is adjacent to angle C, and again the hypotenuse is known, which is the longest side, and again which side is adjacent to this angle for angle 30 degrees, and then which side is opposite to this one. After this, you can find sine of 30, cos of 30 and tan of 30, because you have all the information given here. And again you can find cos of 60, sine of 60 and tan of 60 degrees. The first step, use the trigonometric ratios, opposite over hypotenuse for sine, opposite over adjacent for tan, and adjacent over hypotenuse for cosine, and find the 3 trigonometric values for 30 degrees angle and that of 60 degrees angle. Later you will check the answer. So that use the trigonometric ratios as we did for the first sine, cosine and tangent for 45 degrees angle. So you follow the same step, and then you can determine, or you can find values for sine, cosine and tangent for this 30 and 60 degrees angle, because you have all the required information or the needed information here on this right angled triangle. Okay, now in the next video we'll see examples which is related with 45, 60 and 30 degrees angle. That means finding sine, cosine and tangent of these 3 angles, 45, 30 and 60 degrees. To see this example, in this example we have given, as you can see, we have given triangle, and the side length of BC is 4 centimeters. As you can see here, we have given side BC, which is 4 centimeters, and we're asked to find the length of AD, the length of AD. But look at this triangle ACD. Here, this triangle ACD is right-angled triangle, and in this right-angled triangle ACD, we have side CD, side AC, and side AD. So for this right-angled triangle, this AD is the hypotenuse. It is the hypotenuse for this right-angled triangle. Then as you can see here again, we have BCD, a straight angle BCD. The degree measure of a straight angle is known, which is 180. So if the half part is given by 90, the remaining angle, the degree measure of the remaining angle is 90 degrees. So to find the side length of this AD, the first step is we need to check how many of the sides are given. Now as you can see here, CD is not given, AC is not given, and then we are asked to find AD. The only given thing is here angle D, which is 45 degrees. So that to find this side length AD, at least one of these sides should be given, either AC or DC. But using the information given this side of the triangle, we can find the length of side AC. How? Look at this triangle. This triangle is right-angled triangle. The angle which is given by here is 60 degrees, which is angle B, and that of this angle is 90 degrees, which is right angle, and the side length BC is given by 4 centimeter. So using these two given, that means the 60 degrees angle and the adjacent side, which is 4 centimeters, then we can find the length of AC. So after finding AC, then using the length of this AC and the 45 degrees angle, then we can determine the length of side AD. Okay, now let's find AC, the side length of AC. Okay, what is AC, side AC for this given angle 60 degrees? It is opposite. So we have the opposite side O here. And then what is this side, which is 4 centimeters given for this angle 60 degrees? It is adjacent A, the adjacent side. Now using opposite and adjacent, we can determine the length of AC. Which trigonometric ratios are we going to use? Tan. Okay, then tan of which angle? 60 degrees. The angle is given here, which is 60 degrees, is equal to opposite divided by adjacent. Opposite divided by adjacent. Okay, what is tan 60 degrees? Tan 60 degrees is the square root of 3 or radical 3. I told you in the previous video, I said find values of sine, cosine, and tan of 30 and 60 degrees using the same procedure, because the right angled triangle was given there, the angles were given plus the 3 sides were given. So simply using the relationship between the 3 special sides, opposite, adjacent, and hypotenuse, you can determine the 30 and 60 degrees of tan, sine, and cosine of these 2 angles. Okay, so as I said, tan of 60 degrees is the square root of 3 or radical 3, which is equal to opposite. The opposite is AC, side AC, divided by adjacent, which is 4 centimeters, which is 4 centimeters. Now give 1 as a denominator for radical 3 or square root of 3, then using the cross multiplication, easily we can determine the side length of AC. So what is AC times A? Which is AC equals the square root of 3 times 4 is 4 times square root of 3 centimeters. This is the length of side AC. Now we have side AC, which is given by 4 times the square root of 3 centimeters. But the question is, we are asked to find AD. We are asked to find AD. So to find AD, here we have given AC, which is 4 radical 3 centimeters, which is opposite for this angle D, the opposite side. Still, this AC is opposite. It was opposite for this angle, and again it's opposite to this angle. So we have given AC. But the question is AD, which is the hypotenuse H for this right-angled triangle ACD. Now, which trigonometric ratios use this opposite and hypotenuse? It is sine. So sine of which angle? Sine of the angle which is given by 45 degrees is equal to opposite divided by the hypotenuse. Opposite divided by the hypotenuse. Okay, what is sine 45? Sine 45 is radical 2 divided by 2. We did this in a previous video. We have seen this one. So it's radical 2 divided by 2. The opposite here is, we have given here 4 radical 3 divided by the hypotenuse h. The hypotenuse h, because the question is AD. Side AD means the hypotenuse, which is given by h. So we have the square root of 2 divided by 2 is equal to 4 radical 3 divided by h. Now we use what? We use the crisscross or the cross multiplication. So h times radical 2 is radical 2 h is equal to 2 times 4 radical 3 is 8 radical 3, or 8 square root of 3. So divide both sides by square root of 2. Divide this by radical 2. Again, divide this by radical 2. So radical 2 cancelled by radical 2. So we have what? H, the hypotenuse h. So that h is equal to, here we have h is equal to, as we did, you can rationalize the denominator here. Rationalizing the denominator means multiplying the numerator and the denominator by the same irrational number. The irrational number here given here is 2, that is radical 2. So the same by square root of 2. So square root of 2 times square root of 2, here is the square root of 4. The square root of 4. And for the numerator, we have 8 times the square root of, what is radical 3 times radical 2? Square root of 2 times the square root of 3 is square root of 6. We multiply the numbers under the same square root or under the same radical. So 3 times 2 is 6. Okay, so this is equal to, we have 8 times the square root of 6 divided by, what is the square root of 4? Or radical 4 is 2. Radical 4 is 2. Now after this, you can simplify it. 8 divided by 2 is 4, and square root of 6. Square root of 6, it cannot be simplified, so we leave it as it is, so that we have 4 times the square root of 6. This 4 times the square root of 6 is the hypotenuse for this right angled triangle ACD. So that we are asked, in this example, we are asked to find side length of AD. So AD is equal to, we write as AD is equal to 4 times the square root of 6 centimeters. But here, to find AD, we didn't use directly, or we didn't apply this directly, the 45 degrees angle. Instead, the first step we did that using this the 60 degrees angles, and then we calculated the value of AC, the side length of AC. Later, using this AC in the 45 degrees angles, we find the the side length of AD. So using the same method, the same procedures, and then the same relationship between sine, cosine, tangent, opposite, adjacent, and hypotenuse of given different triangles, you can find values of unknown side length and then unknown angles in a given right angled triangle.